How do you implement a linked list in Golang? Welcome back to my channel. We are going to start a series of data structures in Golang. A linked list is a data structure which is consisting of a collection of elements that together form a sequence. And we know from mathematics that a sequence is a list of items where the order of the items is particularly important. What's specific to the linked list is that each element has two properties. A property data and a property called next. And the next is the next property will be a pointer to the next item in the linked list. That's why it's called linked. You have each element pointing to the next one. We will see exactly how to implement this. This is actually called a singly linked list. The list contains a head property, and the head is first element in the list, and it's called head by convention. The head then points to the next element in the list, which points to the next element, and so on. How do you know that the element at the end is actually the last element? Its next property would be null or nil. It would not point to anything. What you can do with the linked list is you can perform insertion, you can perform deletion of items, fetching at various indexes, or you can do, of course, iterations. And you can write a for each element in the linked list, do something element. Okay. We will also be implementing that. So let's begin with adding the file for the structures. Touch chessmatch.go. So now we begin by describing our package main, type move, chess move struct. We just call it move, and then by convention the elements have a data property, which we will be using a string just for the sake of simplicity. You can also use any kind of type, but for the sake of simplicity today we will be using strings. And then each element has a next property, and what next points to, so this is a pointer to a next element of the exact same type. Okay, then we will have the actual list itself. So we will have a chess match, which is where we'll store the chess moves, right? And this is also struct. What the chess match has is a property called head, and this is the first element in the list. Head, which is of course a move pointer. When we create the moves, we want to really make sure that we respect the convention of populating the data and the next properties. So we should facilitate that by creating a constructor func new move, and this receives a data, which is a string, and receives the next element as well, and it will of course return a move itself, m, which is a pointing address of move, data is data, and next is next. We can also just say, return this. Func new chess match returns a chess match, return the address of C. Of course, you will ask, why do we even need this? The reason why I use it now is just to stick to the same pattern. Generally, you would need these helper constructor functions if you want to populate properties with some sensible defaults. There is no such case here. The only thing that we need to make sure that we populate is that the head should be nil. So you don't need to specifically assign it to nil. So we can just return the address of this here. Func applies to types pointer to chess match, and it's called get at. Okay, so it will receive an index, which is an integer, and it will return a move at that position. For now, we just return nil. We will come back later and implement it. Get last index. No, there is no, and this returns as well a return nil. We will come back to this later and implement it. It's available, of course, on the linked list. So it's called insert at position, and it receives a position as integer, and it receives the data that it should insert there. That's also a common operation. So remove at index int for each. And what this receives, now this is interesting. What this receives is the action that you would like to execute on each item. That action, we would need to have a parameter function, and the type here is a function which operates a parameter of type pointer to move, because that's what the predicate function will operate on. Okay, let's write some unit tests. As you know, by convention, we call unit test files in Golang with _test go. This is, of course, part of the same package. And what we do here is we will now write some unit tests. And what are unit tests? They are simply functions that make assertions. Function test get at some random position, pointer to testing.t, go test. We want to make sure when I have inserted these two items, what's at the second position, for example, it should be see.get at. So now we want to assert that what we actually get from the get at position 1 is the data m2 data, right? Because if it's not, then our insert simply does not work like a linked list should behave. If actual actual.data is not the expected data, error formatted as we expect the element this at position 1, okay, and the element would be m2 data, correct? This is getting at the last position. We just want to test that when we have some items in list and we fetch one, it's actually the expected one. Okay, let's actually also run it. Go test. It fails, of course, because our get at returns nothing for the moment. Let's also add a unit test for insertion, and then we write the implementation. Func insert at random position. So we insert at position 2 and 3 data, and position 3 and 4 data, right? Now we have four items in our list. Now we want to assert that, for example, so we say actual. We will also add unit tests for the edge cases when we insert at the first position and the last. But for now, let's test at some other position. Actual is c.get at, and we want, position 2. Okay. Now let's verify what. So we expect at position 2 m3 data, which is e5. In case that's not so if actual, first of all, does this element even exist? So if it's nil, or actual data is not our expected data, which was m3, so is not m3 data, then something is wrong. We will just throw an error, a formatted error. We will say expected element, and the element that we expect is 3 data. Right, so now we have these two tests. We are testing get here, and we are testing insert. I think it would be a good time to actually implement these methods. Right, so in order to get the element at a specific position, our list has a head, which is an element that has a property called next, which points to the next element, which has a property called next, which points to the next elements, and so on. Okay. What we need to do, let's say we want this element, then we need to iterate from head until we reach this position. Okay, we need to write an iteration that starts with the head. So say current element is c.head, or CRT. It's preferred in Golang to write shorter variable names, and we also need to keep track of the current position. So position is 0. That's where we start, at the head. As long as position is less than the index that we are interested in, and you have an element, so as long as the position is not the one that we want, keep going through the elements. How do we do that? We reassign current to the next of current. So current.next. Then we just increase the position. At some point, the position will be the index that we need. Then it does not enter this. In that point, our current element is the one that we are interested in. So we just return it. Return. In order to test these this get, we actually also need to make insert work. How else would you test getting at a certain point? Because right now our insertion does nothing. First of all, let's think a little bit. We have some scenarios. First of all, our list could be empty. And if our list is empty, what does head contain? The head is simply nil. So if the head is nil, then that means the list is empty. If the list is empty, which means there is no head, then the head will be, remember we have a new constructor to create elements, which is new move, which you receive, and next element. But in this scenario, since the list was nil, what would the next element be? We just pass nil. We also need to return here because we are not interested in doing anything else in this method. What happens if the list had elements already? Let's say the list has 5 elements we want to add at index 3. Let's think a little here. And the head points to the element, and the element points to another element, and the element points to another. If we want to add an element in between here, we want to add here. If we want to add an element here, then we need to be careful because the previous element pointed before to this one. But now the previous element will point to our new one, and the new one will point to what was previously there. Let's do this. First of all, we need to understand what's the previous element at the position that we are interested in. So if I want to insert at position 5, kind of interested in what's at the position 4, first of all, because I need to change its next, okay? Let's fetch the previous. So this is where our getAt method comes in, and we say previous is c.getAt. And what is the previous one? Well, it's index -1. Now that we have this element, the previous element will point its next property towards our new element, okay, which contains this new data. And what does the new element point to as its own next? It points to what the previous next was. So we have essentially shifted our elements with one item because we have inserted a new one. And it was very important to keep updating the next properties so that we still have a linked list. That's all. Let's see, go test. As we can see, now the tests are passing. What was our purpose? We wanted to test, let's see if the get works, and let's see if the insert works. So I hope this made sense. We will be ending now, and we will come back with our second part of the implementation of data structures linked list. Thank you. See you guys next time.